Alright, welcome to Barbaric channel. Today we're gonna cover something very interesting, exciting, at least I think it is. We're gonna cover MIDI. And we're gonna do this with Raspberry Pi Pico, and it's gonna be fun, hopefully. The reason why I'm going to cover this Pico, I have a couple of pedals, like this Boss RC500 loop station that has MIDI in, and I also have this DigiTech Whammy pedal. There it is. Has MIDI in as well. So I thought, why not? Let's try to control these pedals and see where we get, with that. They're wonderful pedals, but those are not the only things we can control with MIDI. Obviously, I'm focused on guitar pedals, but MIDI has been around since the 80s, and there's lots of devices you can control, like digital audio workstations, and, I heard you can even control lights, stage lights. Anyway, I'll be focused on these pedals, and as always, there will be more information on my website, and the link is in the description if you want to have a look. And I would suggest you have a look. So let's see, what are we dealing with? So let me open this up. Anyway, turns out that MIDI is super simple to interface using Raspberry Pi Pico. The hardware itself is trivial, just a couple of resistors, as you can see, and this is connected to UART port of the controller. Now, let's see what MIDI says for the connection. You saw that diagram, but this is MIDI spec. So it is exactly what I showed there. The original spec back in the day indicated 5-volt requirements, but that has been updated since, so we have recommendation as well for 3.3 volts, and this is the voltage we will be using because that is what Raspberry Pi Pico is using. Now, please note that we should be using 5-volt, even though Raspberry Pi can supply 5 volts over VBus. We shouldn't use that, even though, in some on some web pages you have this old specification for 5 volt only. We shouldn't be using that because 5 volts could potentially damage Pico. What it does is actually, on the input side, it has optocoupler, and we are controlling LED of that optocoupler to control our target device. Now, there is a voltage drop on that LED, but you shouldn't be really connecting to 5 volts. So we have 3.3 volts. There is a resistor values that are suggested. Now I have to say I didn't have 33 ohms, I had 47 ohms resistor. It doesn't really matter, it will work. I even tried 220 ohms and it worked with my Boss RC500. Again, we just need to know that there is optocoupler on the other side, and we should be just aware of what we are connecting to. And if you log in, you can log in and get more details on this with how does it look like at MIDI output, MIDI input, and we have all these details here. 31.250 bits per second. This is our baud rate, and this is how to set up. Everything is really here. If you notice, there are two types of connectors. My RC500 uses TRS cable, and my Whammy uses DIN5, and DIN5 has 3 different types of freaking connectors. So just be careful. It's 180 degrees DIN5. This specification has been updated, to support TRS. And if you look at it, this is how connection goes. So here 4, 5, and 2 are pins that are used, the only pins that are used on DIN5, and here how to map them. As it happens to be, because this was not standard from the beginning, luckily that's what BOSS supports, and you can see it here. It's the same connectivity, so this is great. We are supporting BOSS, but I want to make sure that we know that this is not the kind of or may not be always the case. So be sure to check manufacturer's manual, because there might be different wiring for different manufacturers. Okay, and now that we have configuration, so actually what I wanted to show as well is because I have two, so this is the minimum what we can have. And if you look at this diagram there, where is it? It shows this TRS to DIN connector cable. I don't have it. I have just DIN 5-pin DIN cable, just standard MIDI. So that's what I'm going to be using here. So for that reason, I'm going to do, if I can only change this. I promise I have another diagram there with DIN 5 connector. Yeah, there it is, right? So, I've hardwired it here, but that's probably not the greatest idea of all ideas I had. But, I'll be using pedals independently. So I will have one connected at all times, so that won't be a problem. Having said that, this Raspberry Pi Pico has 2 UARTs, so we can have 2 ports, MIDI ports, output MIDI ports. So that is good. So let's see. Where's my breadboard version? So this is my breadboard version of the pedal. 2 resistors, some wires, my TRS jack, and my other DIN jack. Just be careful how you wire them up. This is red is 5, I believe. No, it's 4. This one is 4. This one is ground, and this one is 5. So just have a look online how to about pinout, but this is how it should be done. So this is simple, right? I showed before. If you want to look at it, look it up. How to wire things up. This is pinout, and if I zoom in a bit, and you can see here UART 0 transmitting pin is all we need, and we get this 3.3 volt and ground. That's how it's wired up. Extremely simple. Now let's use, what are we going to use? So I'm going to use for programming of this, and I decided to go with MicroPython. I did this before. I dabbled a while back with this Pico and MicroPython, and I use Visual Studio, Microsoft Visual Studio Code for this, and it used some extension. That extension got obsolete. There's a different version of it. Long story short, I broke my Visual Studio Code, not because of that extension. It was just like, who knows what I did meanwhile, with that. So I couldn't be bothered fixing it. So I used what seems to be the integrated development environment, IDE of choice when it comes to MicroPython, and this is Tony. And this is super simple to use. Now my Pico is connected to USB, and it immediately appears here. and I can send commands to it, you know. But say, for example, I just want to show you how easy it is to actually use this. So and how to configure it. So if you go into this boot cell mode, if you want to install a new firmware for MicroPython, for example, I'm just gonna, you hold the reset button and you plug in USB, and what's gonna happen is it's gonna go into this programming mode. That now what I can do is, if I go to options and I go to interpreter, I use MicroPython and I use Raspberry Pi Pico here, and port I connected, try to detect port automatically, and it does a good job. You don't see here now port Pico because it's in programming mode. But if I click here, it shows my Pico, because it appears as a new drive so you can drop firmware there, and then you can choose MicroPython variant. I can use, mine is Pico, normal Pico, it's not the wireless version, and you have other stuff here. It's quite actually good. I have to check. I have some. I'm gonna use this later on at some stage, but I have this one, and you can see here. You just select the firmware and you just click install, and it's gonna do the job. And it tells you here, gives you instructions what to do. You do this boot cell button, and restart. You plug in this again, so it goes to this UF2 bootloader, blah blah. You can read that up. So I'm just gonna unplug it and plug it in back again. So I go into normal operation mode. So right, and here it should appear as. It doesn't appear there, but let's go options, and I have it here, Okay, and you can see it reappeared here. Software. I'm gonna go real quick through this. I'm gonna copy paste some of this, but it is quite simple. Okay, so I'm gonna use this interactive console here. I'm just gonna actually just scroll in, and I'll put all this on my web page. Just make sure you have a look at there. So this is it. One line and 2 lines. This is it. My MIDI port is configured. 2 lines. Very simple. Now, how do I know what to do there? And it's not really. It's all here, in the dock. Very simple. 8 data bits, no parity, 1 stop bit. It's all there. Very simple. Now, what do we send there, and what do we do with the? How do we actually use this? Okay. Let me go through this. For this, I would need Boss manual. Now, if you go through here, and you can search it up, like Loop Station RC, Boss RC500 owner manual, you'll find that. So let me, controlling devices via MIDI, and this is normally what you're gonna get first, owner manual. But interestingly, for details on each of the MIDI setting parameters, refer to parameter guide. Okay, so we'll look it up real quick in a minute. But here, it gives us details of how to use this, MIDI device. We can transmit start and stop. You can see here that actually there is output. MIDI output there, but we want to see how it is receiving messages. So we can do some tempo and MIDI sync with this. I'm not going to look into that. I'm not looking into this MIDI start. What I'm more focused on is this here switching memories. So there is this program change message. So these cannot be received. Okay, so we are talking about 1 to 99. So program changes from 1 to 99. Program change is a MIDI message. So we'll have a look at that. Oh, you can see here control change 0. What does this mean? I'm not sure. We'll have a look at that. Because control changes here are different. So what, oh yeah, so control change 0 and 32 are not used, I suppose. And control changes from 1 to 31 are used. And then you can use 64 for 95. And it says here, assign settings. There's 8 assign options, and you can set up these control change 1 to 31 and CC 64 to 95. So look up this parameter guide, and you can go and see here. This is very comprehensive, you know, like how to set up everything. I looked it up, you know, and here you for assign 1 to 8, you assign them on if you want to use MIDI, and you go and change your, you know, source to CC. I'm going to use 1 and 4. You change this, you know, is it momentary or toggle? I'm going to use toggle. The reason why I'm going to use toggle is because I'm going to send messages directly to my MIDI device, so it's going to be hard, you know, like I'm going to type those messages, so it's going to be hard to keep sending messages there. So I'm just going to use toggle, and then you have all these targets, you know. So I'm going to do play stop, and I'm going to play maybe with reverse and maybe FX. This is just easiest to show the details, but you can go and this is really it's really comprehensive, and have a look at that. But what are these messages? Control change and program change. So if you look at, there is a, you know, summary of MIDI messages on MIDI official website, and here I can go and find my messages. Where is that? Okay, so I have control change here. Control change, it says it's 1011. This is, what is this? 1 3 11. So this is B, message B, hex decimal, and NNN. This is MIDI channel. Now we're going to use omni-channel by default. Both RC500 and this other Whammy use, you know, they can receive on all channels. We can go. This is interesting, you know, like if you want to chain these MIDI MIDI devices, because, for example, Boss has MIDI out. I'm not sure if it has MIDI true and if you can configure that. But if you had MIDI true, you could daisy chain these MIDI devices, and then, you know, you can control them on different channels. And you can set that up on both RC500 and Whammy pedal. But we're going to use all zeros in this case, you know, all zeros. The next one is the message. And it says, you know, this actually control the second. So there are 3 bytes sent. So this is the first one. What is the control? What is the message and the channel? So it's going to be control change, and we're going to use all zeros. And here it's 0, and then it has 7 bits for controller number. And remember that this is CC1 to CC whatever is saying here, CC 31 and CC 64 and 295. So if you send 1, I'll use 1 and 4 for no particular reason. That's just, it was easy for me to set it up that way. You can use anything, you know, that is supported. And then we have value, and this is interesting because value is from 1 to 100, from 0 to 127. So this is 7 bits. The 0 will mean in our toggle is going to be off and 127 is going to be on. But how toggle works, we'll get to that. I just realized that now that you need to do off and on. It's a toggle, so it works on changing the value from 0 to maximum. This is going to be interesting because for Whammy, we can use any value here in some cases to control Whammy. So we'll see that. And now we have these program changes right here. This is just sending the new program. So here this is C hexadecimal, this is 12. And we have, again, channel, we're going to use 0. And here we're going to use programs. And this depends on what we're going to use. I'm going to use program 1 and 22 on my looper because I recorded nothing special just for this demonstration, but I'm going to use 1 and 22. Just why 1 and 22? Just so it's not 1 and 2. All right, so that is covered what we're going to do. So let's plug it in. I'm going to plug in my pedal here. I'm going to use my cable from my headphones, I suppose. I'm just going to plug it in here. And make sure you MIDI in. In order for this to work, I have to plug in. I'm not going to record anything, but I need to plug in things here. Otherwise, the pedal won't power on, and you can see that now. Where's my guitar plug? And of course, I plugged it into the wrong place. I'm going to turn on my... I don't know if this is visible. Oh yeah, maybe we can see this. Okay, so I just put memory 17. So how is this going to work? Well, I have this configured. So let me just send one command. And as I said, I'm going to use CC1 for start and stop. Okay. So I'm going to just define these, CC1. This is B is whatever that binary code is for. This is hexadecimal. So it's B is 11. This is our control change. 1 is our control change 1. And we have 7F, that's 127, that's maximum value. And I'm going to do the same thing for CC1 off. So it's the same command with just 0 value. And I'm going to use CC4, the same thing. You see the same command for 128 and for off. And this B is just binary string, and you'll see how to send that. So now I'm going to use this PC. This is program change, and this is 1, and this is funny. It's 0 index, so value 0 means memory location 1. You have to read the manuals and whatnot, maybe. But this is for Boss RC500. And we have here, this is PC22. These are my commands. This is 16, because it's hexadecimal, this is 16 plus 5, 21, plus 1. All right, so the simplest thing to show here is that I'm just going to change these command values. I'm going to send this program change, so I'm going to change memory locations. And let's see that. So it's very simple. MIDI.write, and we need to use byte array for this to convert this these strings, so I'm gonna go PC1. So I'm just writing PC1. And nothing changed, nothing happened, right? Let's see if I plugged in correctly everything. Okay, let's see if some other configuration is wrong. Let's reset again. Okay, maybe we have to do this here, right? And as you can see, sometimes things don't work as well as you planned. But anyway, it is working now, and you can see I can change these things, right? Okay, I hope this is visible on the... Oh yeah, it is actually visible on the recording. So I'm just gonna go quickly and show you what I did for this configuration. So I have something recorded, but let's... All right, let's see what I did to configure this, you know. So first of all, I recorded something here just for the experimentation here. So memory, you go to memory and assign, and you see I turned it on, assign. I chose source CC1, so you know you can go and you see you can change lots of different options. C1, but this is important because if you don't configure this correctly, you know the device won't recognize these values. So toggle mode, you know, momentary or toggle, and then we have target. So there's lots of options. You know, you can see here there's loads of different options that you can play with. I'm just gonna do play stop, and I assigned 2 as well, and source is CC4 because that's what I'm going to use, and toggle again, and target is T1 reverse. So what it's going to do is going to reverse the loop. Okay, and this is just so it's easy to see that it's working actually. So let me just send this commands. So as I said, like it's a bit, this toggle works. You need to send off. So I'm going to copy this and then on. Can you hear it? Yeah, it's working. Great job. So let me send oops, command 4. Ah, it's working, yeah. It's totally weird, right? The sound. Yeah. So let me turn it off. Ah, can you hear that? So, and I'm just gonna stop it. Brilliant. That's it. So let me change to PC22. Okay, it's there. This one I configured differently. I turned on this FX loop, and in memory I set up this assign to same. Everything else is the same. I just put loop FX. So what it does, this toggles between on and off of the loop. If you put it on T1, if you put this on T1 FX, it actually controls whether loop is enabled or disabled there. So I don't think that's going to work. Choose loop FX here, and I just put anything, any loop, you know. it's off. So when I use MIDI there, it will turn it on, and I use scatter too. Doesn't really matter. So just something to demonstrate this. So let me play the loop. Yeah, nothing really inspiring in that sound, but let's turn on the scatter. Ah! What would you know? It's working. Alright, so let's switch this off. Okay, hopefully that makes sense. So let me unplug all of this and let's plug in Whammy. Whoops, I should probably turn this off. Whammy. Okay, let's put it like this, for example. Okay, and for this I'll have to play guitar because it won't work. I won't be able to demonstrate this otherwise, but let's plug this in. Way easier with TRS cable. Okay, so here we turn on the okay. So how do we configure this? Let's see. So again, you know, we read the manual. There is a MIDI configuration down there somewhere, and this is a bit different. So here it tells you how to configure the channel. Doesn't really matter. We won't use that. By default, it's using Omni. But here we're going to use different thing. You know, program changes are controlling this. So this is a bit different from what we had for for RC500, where program change was changing memory location. Here, well, you know, it's similar thing. So what this does is, you know, active is going to be 1, bypass 22. So it's just going to turn it off. So 1 is going to activate. So I'm going to use this octave, 2 octaves Whammy, and then we can use this, for example, 4, 5 here. So 16 and 37, for example. For example, this is how, you know, if you send PC this program change with number 1, it will turn this on. If you send with 22, it will turn it off. Likewise, you know, you have it here. You can do the same thing in chords mode. This is classic mode. You can do it there. An interesting part here is MIDI continuous control, because pedal has this expression pedal. So what it says is, if we use CC11, so it's control change 11, that will adjust our expression pedal, and 0 is toe up and 127 is toe down position. So anything in between is something in the middle. But as you can see here, you know, in this, when we do it here, it will make a difference. Here is only toe up and down, you know. So with that in mind, so I already turned on CC1 on, and, you know, like I already have these 1 and 22. Part of the reason why I'm choosing these values, PC1 and 22, and I just need to add this 16 and 37 here, and I'm going to use this CC11. So I'm not going to go into details of that. You know, it's same thing as we had before. Toe up 0, 0, toe down 7 F. And I'm just going to use two other positions, just, you know, for fun. 16. This is okay, so it's all the same. So control change, controller 11. F is just, it's actually 15. Yeah. Okay, I'll leave it 16. And then here I said 68. I probably made a mistake there. Oh no, it's correct. 4 times 16 is... I made a mistake here, probably. It's 67, probably. Anyway, it doesn't really matter. The whole point is to get a different sound. So let me change program first. So let me do this MIDI write thing. MIDI.write byte array. And I'm going to use this PC1. And if you recall, this is going to turn on octave, 2 octaves up. It did, and it, you don't see it here. I'm just going to, it turned on. I'm just going to bypass it, okay? Huh? Can you see that? Turned off there. And you maybe you can even hear the click. There's probably a relay inside. So let me just turn it on. And I'm not going to play anything too complicated, just for the demo. Right, it's on, right? So let's say I send CC toe up, right? And it's hard to type and hold guitar. So toe up, toe down. Okay, can you hear that? I hope you can. So let's try the things in the middle. What did we say? Toe 16 or 15. All right, and let's try 68, 67, whatever. Hey, it's working, right? So let me bypass it. Right, it's working, we're getting there, right? So let me, what else did we say? I said 16, right? This is 16. Let's do that. Let's turn that on. Hey, look at that. Bleh. Let's see, toe up. Toe up is fourths, and toe down it's there. It's working. Nice. Let's turn it off. Ooh. Oh no, it's PC. Sorry. Okay. I should probably tune the guitar. I promise you it was Whammy, not my detuned guitar, making those sounds. So that's it, I suppose. Like, I mean, make sure you have a look at my web page for details. This is, I think, it was for all this. You know, you don't need to type or copy from my video, but like, this was relatively simple, you know, even though it took us quite a while to get to this point. Very simple interface. Programming, it is relatively simple as well, you know, like there's nothing super complicated there. Now it's going to get more complex, obviously, because lots of these videos, they just go and show you this, what I'm going to do. I'm going to continue with this because I want to make the pedal work, you know. So the next steps are to add a stomp switch and an LED and see if we can make this more useful, because this is what we want to achieve, you know, like this is our next goal, is stomp switch and LED, but that we'll need to deal with some other programming things, you know, how to deal with buttons and how to deal with LEDs. Makes sense, but it's not as trivial as it may sound. So until next time.